inverse Z transformation. So we'll see the definition. Normally Z transformation means is a transformation or it is a process taking time domain function to Z domain function. That is, time domain function is small f of n. Z domain function is capital F of Z. So we'll take Z of capital Z of f of n is a transformation of time domain function, which is equal to capital F of Z. So from the definition we know summation n is equal to 0 to infinite f of n Z power minus n. So in Z domain function, Z, that is Z domain function. So we are taking capital F of Z. In time domain function, we are taking small f of n, right? So inverse transformation is the reverse process of this. So it will convert Z domain function to time domain function. That is capital F of Z to small f of n. So it will denote by Z inverse of capital F of Z, which is equal to small f of n, right? So a process of finding time domain function f of n from its Z transform capital F of Z, that is denoted by Z inverse of f of Z is equal to f of n. If Z is Z of f of n which is equal to f of Z, then the unique inverse transformation of f of Z is given by Z inverse of f of Z is equal to f of n. So some notations we are using in some problems. So f of n can be denoted by f of suffix n, right? Sometimes they will use, instead of capital F of Z, they will use u of Z, right? Whenever they are using u of Z, the time function should be in the form of u of suffix n or u of n. As we know previously, u of n is the standard notation for unit step sequence or unit step function. So right, so based on that you have to carefully use the notations, right? The inverse transformation can be find in the following forms. Following methods means there are 6 methods to find inverse transformation. One is direct method. Next one is, second one is that is direct division, polynomial division, and third one is partial fraction, the standard method, partial fraction method, and fourth one is residues method using Cauchy's integral, that is the inverse integral method, right? And fifth one is using power series expansion, right? And last one is convolution theorem, using convolution theorem. This residue and convolution theorem are most useful in many problems, right? They are very useful method, right, to find the inverse Z transformation. So we'll see the first method, a method of inspection. Inspection means inspecting the coefficients of the given series, right? From that we can easily find the time function small f of n, right? We'll see the method. This method we can find the inverse Z transformation directly by observing the coefficients of the given series. Let us see a problem. Find the inverse transformation of the series 1 plus 1 by 2 power 2 into Z power minus 1 plus 1 by 4 Z power minus 2 plus 1 by 8, etc. Let us take capital F of Z, which is equal to given series 1 plus 1 by 2 Z power minus 1 by 4 Z power minus 2 plus etc. So this can be written as 1 plus 1 by 2 Z power minus 1 plus 1 by 4 can be written as 1 by 2 square Z power minus 2, and 1 by 8 can be written as 1 by 2 cube Z power minus 3. But 1 by 2 square can be written as 1 by 2 the whole square. 1 by 2 cube can be written as 1 by 2 whole cube, right? So this can be written as in the summation n is equal to 0 to infinite 1 by 2 power n Z power minus n is equation number 1. Now we know Z transformation formula Z of f of n, which is equal to summation n is equal to 0 to infinite f of n Z power minus n. This is equation number 2. Left hand side of 1 and 2 are same. capital F of Z, capital F of Z. Therefore, right hand side equal. Therefore, summation n is equal to 0 to infinite 1 by 2 power n Z power n minus n, which is equal to summation n is equal to 0 to infinite f of n Z power minus n. Right? Now we can compare both sides. Here left hand side the summation is starting from n is equal to 0 to infinite. Right hand side also the summation starting from n is equal to 0 to infinite. And in the left hand side you are having f of n, but in the right hand side you are having 1 by 2 power n. Left hand side you are having z power minus n, and right hand side also z power minus n. So when comparing these two, easily conclude that f of n is equal to 1 by 2 power n. Therefore, the inverse z transformation of given series is nothing but 1 by 2 power n. Right? Next problem. Find the inverse z transformation of z cube by z minus 1 the whole cube. Let us take capital F of z, which is equal to z cube by z minus 1 the whole cube. Now taking z outside from the denominator, right? So you will get z cube by, so when you are taking z outside from z minus 1 the whole cube, so you will get z cube outside, right? So z cube by z cube into 1 minus 1 by z the whole cube. Z cube and z cube get cancelled, so you will get 1 minus 1 by z whole cube in the denominator. This can be written as 1 minus 1 by z power minus 3. So because 1 minus 1 by z cube in the denominator, when it comes to the numerator, it will become minus 3. 1 minus 1 by z whole power minus 3. We know the formula 1 minus x power minus 3, right? 1 plus 3x plus 6x square plus 10x cube plus etc. etc. So instead of x you are having 1 by z. So you will get 1 plus 3 into 1 by z plus 6 into 1 by z square plus 10 into 1 by z whole cube plus etc. etc. So to write it in the standard form summation, so you need the nth term of this series, right? Then only you can write summation the nth term, right? Normally we write like that. A summation n means 1 plus 2 plus 3 plus etc. etc. plus n nth term plus etc. etc. Right? That nth term only we are writing whenever we are put it in the notation summation. So for that we need the nth term of this series. So first check the numbers. First 1, 3, 6, 10, right? But this 1, 3, 6, 10 is the standard numbers, that sequence, right? 1, 3, 6, 10, etc. etc. is called triangular sequence, right? So for that nth term we know n into n plus 1 by 2, right? Otherwise you have to check each numbers, write the numbers 1, 3, 6, 10, then find the relation between these numbers. Then you can write the nth term. See, first term 1, right? Second term, right? 3 can be written as 2 into second term, right? 2 into 2 plus 1 by 2, right? Third term 3 into 3 plus 1 by 2, right? Then 4 into 4 plus 1 by 2, right? Therefore nth term n into n plus 1 by 2, right? And 1 by z, 1 by z square, 1 by z cube, right? 1 by z power n minus 1, because in the second term you are having 1 by z power 1 only. Second term 1 by z power 1. So when you are putting 2 into 2 plus 1 by 2, instead of n you are putting 2 into 2 plus 1 by 2. So power should be less than 2, that is 2 minus 1. So n minus 1. So 1 by z power n minus 1. So you can write it as, right, n into n plus 1 by 2 into 1 by z power n minus 1 plus etc. etc. Right? So we can use this also, triangular sequence. That is equal to summation. So starting term 1, right? So n is equal to 1 to infinite n into n plus 1 by 2 1 by z power n minus 1, not n minus 1, right? So change it to n. Replace n by n plus 1. Then you will get n equal to 0, right? So if you are taking n equal to n plus 1, then n plus 1 equal to 1 to infinite in the summation, right? Previously. So taking that plus n to the right side, we'll get summation n is equal to 1 minus 1, 0. Right? You will get 0. So it's equal to summation n is equal to 0 to infinite. Replace n by n plus 1. So n plus 1 into n plus 1, right? So n plus 1 into n plus 1 plus 1 n plus 2 by 2. Then 1 by z power n minus 1, right? Replace n by n plus 1. So you will get n plus 1 minus 1. You will get. So summation n plus 1 n plus 2 by 2 into 1 by z power n. So that is equal to summation n is equal to 0 to infinite n plus 1 into n plus 2 by 2 z power minus n. This is equation number 1. So from the z transformation, we know f of z, which is equal to summation n is equal to 0 to infinite f of n z power minus n. Comparing 1 and 2, you will get summation n is equal to 0 to infinite f of n z power minus n, which is equal to summation n is equal to 0 to infinite n plus 1 into n plus 2 by 2 z power minus n. So clearly f of n is equal to the coefficient n plus 1 into n plus 2 by 2. Therefore z inverse z transformation of z cube by z minus 1 cube is n in n plus 1 into n plus 2 by 2. Thanks.